Welcome to qnawire.
Problem 135 asks to find the centroid of this volume where the surface is given in the equation shown. And the centroid in the x and z direction can be found using symmetry, where in the x direction the centroid is going to be equal to half of its width, a over 2. And in the z direction, the centroid will be equal to half of its length, or b over 2. To find the centroid in the y direction, we'll use the equation where the centroid times the total volume is equal to the integral of the centroid of an element, dv, and the element will integrate across this volume. It's going to be a cube, a bunch of small cubes, with one side being dx and the other side being dz, change in z, change in x. And for that filament or cube that we're integrating, the centroid of that element in the y direction is going to be equal to 1/2 y, because it's a cube, so 1/2 of its height, essentially. And now we need to find the volume for this equation to find the centroid. And the volume is equal to the integral of the differential volume of that element. The differential volume of that element is going to be base times width times height, so y dx dz and we can plug in for y because we're given this area, we're given the equation of the surface in terms of y. So plugging in that equation we're given in the problem, we get that dv is now equal to 16h over a squared b squared times ax minus x squared times bz squared minus z, bz minus z squared, rather, all divided by and then multiplied by dx dz. And now we can start the integral for the volume. You have to integrate across x and z direction for this volume, from 0 to b and from 0 to a. Now we can plug in dv. Now solving the first integral, we're left with the constant 16h over a squared b squared on the outside of the integral, times the integral from 0 to b, bz minus z squared, times a over z x squared minus x cubed over 3, from 0 to a dz. And then simplifying further and solving the integral in the z direction. We get an a cubed over 2 minus a cubed over 3 times b over 2z squared minus z cubed over 3 from 0 to b. And plugging in from 0 to b, we get that the volume is equal to 4/9 times ABH. Now the next part we'll need to get is the right side of the centroid formula, which is the integral of the centroid of the differential element. And again, we'll integrate in the x and z direction from 0 to b and 0 to a. We found the differential element to be 1/2 of y, and we'll plug in our equation for the surface area for y. And then we have to multiply it by dv, which we found earlier. It'll just be this equation for y times dx dz. And so simplifying this so that we can integrate it, you get 128h squared over a to the 4th b to the 4th. Integral from 0 to b and 0 to a of a squared x squared minus 2ax cubed plus x to the 4th times b squared z squared minus 2bz cubed plus z to the 4th dx dz. And solving the first integral, we are left with this. And solving this final integral, we are left with this. And plugging in from 0 to b and simplifying, we finally get that the integral of the centroid of the differential element is equal to 32 over 225 a times b times h squared. And now we know enough to find the centroid by using the equation. The centroid times the volume is equal to the integral of the centroid of the differential element. We can plug in the volume we found first, which is 4/9 ABH, instead equal to the right side, which is 32 over 225 ABH squared. And solving for the centroid,